So today we'll learn the TCP IP model. So in previous class we learned OSI model, topologies, data presentation, network criterias, and what are the network types. All things we learned client and server architecture. So we will see the TCP and IP model. Here a protocol suits in a large number of related protocols that work together to allow network computer to communicate. Means protocols means what? There are the set of rules that should have to followed. So here related protocols that work together to allow networked computer to communicate. So while the computers are communicating with each other, that time certain rules have to followed by the network, and that network rules we call the protocol. So here we have the application layer, which has the processes which specifies the addresses. At the transport layer we have SCTP, TCP and UDP, which is port addresses. Like one computer has its own IP addresses, MAC address, so like that we have the connections, so oriented connections, right? And that connection we call that in connection we have different type of connection: TCP, UDP, SCTP. These all are the connections. Now coming to network layer, we have IP and other protocols. That logical addresses are resemble or stored at the IP and other protocols. At the data link layer and physical layer, we have underlying physical network, which is the physical address of our system. So now coming to the application layer has its own protocols, defines the rules when implementing specific network applications. So it's rely on underlying layer to provide accurate and efficient data delivery. So when we follows the set of rules on the applications, that gives ensures that the whichever data is presented or transforming, that is accurate and efficient way to delivered. Okay, so we have your typical protocols. If we are transferring file, we use the FTP, that is file transfer protocol. If we are remotely connecting with any other network, so here we have telnet, that is a remote terminal protocol for a remote login on any other computer on the network. SMTP like specially use it for mail transfer. It means simple mail transfer protocol. HTTP are web browsers, like when we open the Google and other Firefox browser, that time we use the HTTP, which is hypertext transfer protocols. So these all functions, OSI model layer, application presentation and session are the same for this, which uses the certain protocols to follow to deliver the data accurate and efficient way. We have the transport layer. So we saw the application, now transport layer we have TCP UDP thing. So TCP is a connection oriented protocol. So here what connection oriented means, always we think the wire cable connected, but it does not mean that. It has a physical connection between sender and receiver. So TCP provides the function to allow connection virtually also by using the virtual circuits. So coming to UDP is dividing a chunk of data into segments where reassembly the segments into the original chunk and provides further the functions such as reordering and data resending, all things, where offering a reliable byte of streams delivery services to the UDP. So functions the same as the transport layer in OSI, but here we have UDP, byte stream delivery services. So where at the TCP we have a connection between the physical devices, but we can use the virtual circuit where data is not be divided into chunks. There we have the segments. a segment of segment packets, frames kind of things. Here reassembling segment will be done at the network layer, network or transport layer. So here we are offering a reliable byte stream delivery services. So whatever functions has the TCP layer in the OSS, same it has, but here synchronization source and destination computer to set up the session between respective computers only. So it's not on the protocol types, it's on the its own system or computers. We have the internet layer. So network layer, also called the internet layer, it deals with packets and connects independent network to transport the packet across network boundaries. So network layer protocols are IP and internet control message protocol, which is ICMP, which used to error reporting purpose. Here we have host to network layer. So host to network layer is the lowest layer of the TCP and IP. So you know TCP means transport control protocol and internet protocol. So here it reference models to it combines the link layer and the physical layer, like data link layer and physical layer of the ISO and OSI model. So at this layer, the data is transferred between adjacent network nodes in the WAN, that is wide area network, or between the local area network, as same it can be. So here we have TCP IP model and its relationship to protocols of TCP and IP suite. So we here application layer, which has SMTP, FTP, STTP, DNS, TF, TF, RIP, and these all things. So these are the some of the protocols which used or which followed by the application layer while transferring the data. At the transport layer we have TCP and UDP. You know that what is the TCP, what is the UDP. Now we have the network layer. At network layer we have RAP, RARP, IP address, IGMP, ICMP, all things will learn the later in details. So here we have network interface layer, which is connected to the Ethernet by like each of Ethernet has its specifications, wireless connections. So 8.0.11.11 wireless LAN is normally used for Ethernet connection of the network, and frame relay also count the delay of the network connections, and ATM also used at the network interface layer purpose. So OSI model and TCP model. So in the OSI model we have the 7 layer of, and TCP model we have 4 layers. So 4 layers, you know, right? That is application transport network, and these two combined in one, that is data and physical layer are combined into the one. So we have 4 layer. So in OSI model, a strict layering result in vertical layers, but in TCP and IP we uses a loose layering result horizontal layers. So OSI support both connectionless and connection-oriented communication in the network layers, but only connection-oriented communications in transport layer, where TCP/IP supports only connectionless communication in the network layer, but both connectionless and connection-oriented communication in transport layer is also possible. Now, where OSI module it distinguishes between the services interface and protocols. So we know the services is different, interfaces are different, protocols are different. At the TCP and IP model, it does not clearly distinguish between the services, interface, and protocol, because in OSI model for servicing purpose we have the session layer, presentation layer, again the our data link layer, interface, application layer, protocol we have in all the layers. So it differentiate between what layer exactly giving what services or interface or protocol. But at the TCP and IP model, we does not distinguish the services, interface and protocol, because TCP has its own advantage and disadvantage. IP also have its own um, advantage and disadvantage. So the interface and services protocol are not clearly mentioned over there. So coming to ASM model, protocols are better hidden and can be replaced relatively easily as the technology changes. But in the TCP and IP, protocols are not hidden and thus cannot be replaced easily. So here replacing IP by substantially and different protocol would be virtually impossible. When coming to OSI, it refers the model was devised between the corresponding protocols were designed. At the TCP and IP, it came to first. Protocols came first, and the model was a description of the existing protocols. Because at the TCP and IP, we follow set of rules like length of IP addresses. Then TCP also had its length of the package segment to be transferred. So here we followed mostly protocols. At the OSI model, we refer the protocols, but it cannot be says like it come first to be served on OSI model and TCP model. So we learned OSI model, TCP IP model. Here is the internet layer, which is a host network layer. We learn the application, this 4 layer internet and network layers. Here we learned the TCP and IP model, what exactly we have in. Thank you.